Section 1.5, adding integers. We're going to look at two ways of adding integers today. We're going to look at modeling, and we're also going to look at adding by rules. Here, let's take a look at modeling. When adding integers, we can use tiles that represent positive and negative units. Here, I have the yellow square that will represent a positive unit, and a red square that will represent a negative unit. So let's take a look at an example. I'll write an expression for each model, and then I want to find the sum. So as stated before, we know that the gold are positive and the red are negative. So here I have 1, 2, 3, 4, 5, 6 positive units and 4 negative units. And if I would take a look at this, the positive unit would knock out a negative. And if I do that, that would leave me with a positive 2 units. Down below, I have 1, 2, 3, 4, 5, 6, 7, a negative 7 units, plus 1, 2, 3, 4, 5, 6 positive units. Now I can find its sum by canceling out. A negative will cancel out one positive. And after canceling out, I see I'm left with 1 negative unit. So here, 6 plus a negative 4 is 2, and a negative 7 plus 6 is a negative 1. I can do the same thing using a number line. Red will be negative, and my black line will be positive. So I want to write an expression for each model, find the sum. In this situation, I have a negative 10 going to a negative 4, but I can count the units. 1, 2, 3, 4, 5, 6. That would be a negative 6 units, plus, again, have another red segment, 1, 2, 3, plus a negative 3 units. And I can actually count 1, 2, 3, 4, 5, 6, 7, 8, 9. A negative 6 plus a negative 3 is a negative 9. Below, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a negative 10 units plus 1, 2, 3, 4, 5, 6, plus 6 units. And there's some, I'm going to count the same way I did with the blocks. Each positive unit will count off 1 negative unit. So this will cancel. This one will cancel with this. And what I'm left with is 1, 2, 3, 4, a negative 4. Now what I want to do is to draw a model and then find each sum. So here I have a positive 3 plus a negative 7. Remember, the yellow is positive, my red is negative. So in this situation, I'm going to bring down 3 positive units plus, and now 7 negative units. And now I want to find their sum, and I can just cancel. 1 positive cancels 1 negative. And what I'm left with is 1, 2, 3, 4 negative units. Similar example, I have a negative 5 plus a negative 4. I have a negative 5, again that's my red. Plus a negative 4. And now I want to find their sum. They're all negative, so I can just add up all the red blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. A negative 9. If we go back and take a look at the modeling, we can see that we can set up rules to adding integers. For example, on here I have a negative 5 plus a negative 4. In this situation, notice I combined all the tiles and got a negative 9. But on a previous slide, you could see I had positive and negative integers. In that situation, the positive knocked out the negative or vice versa, and I actually had to subtract the integers to determine the value. With that in mind, with different signs and same signs, we can actually come up with rules to adding integers rather than building models each time. And you don't have to always use a gold and a red. You could use squares and triangles and designate one positive or negative. So you don't have to use color blocks. You can just do different shapes. But that can take a long time. Therefore, we come up with adding integer rules. So at this point in time, I need you to actually pause the video and to write these rules down and then apply them on the next few slides and also in your assignments and also sections to come. Therefore, adding integers by using rules. The first thing we want to do is to copy the problem from the board, which we always do. Then we want to find the sum of two numbers at a time, then proceed if needed. So we only use these rules with two numbers at a time, not more than that. And here are the two rules. The one is, if the two integers are the same sign, if they are the same sign, then we want to combine the two integers and use the sign of the given integers. So if they're both positive, you add them and the answer is positive. If they're both negative, add them and the answer is negative. On the other hand, the two integers have different signs. In that instance, I want to subtract the two integers, the small from the large, or the large on top, and subtract the smaller number. And then what I want to do is use the sign of the larger number. Well, I do know that the larger number is always positive, but the numeral itself, the absolute value of them, which one is actually bigger, and then use the sign of that number. So write these rules down, and then we'll continue. So I'm assuming you've written the rules down, and now what we want to do is to apply these rules rather than use modeling blocks in numbers such as this, because that would take forever. So let's do this by the rules. The two numbers here are the same sign. So we're going to copy the problem, and we notice that they're both the same sign. They're both negative, so same sign combine. When I do that, I'm going to combine the two numbers. That means I'm going to add them, which is going to give me 56. And then I want to use the sign of the two numbers. Therefore, it's negative. As you can see, this is a lot faster than if I had to model that set of numbers. Number two, negative 12 plus a negative 5. And don't let the parentheses fool you. You can see what we're doing is we're adding a negative 12 plus a negative 5. Same sign combine. 12 plus 5 is 17. Use the sign, negative 17. Number three, I have a negative 16 plus 13. In this situation, the signs are different, negative and positive. Therefore, what I want to do is subtract. I'm going to subtract 16 minus 13. That's going to give me 3. So my solution is 3, but what I want to do is use the sign of the larger number. So here, 16 is bigger than 13, and 16 is negative, therefore my answer is a negative 3. Continuing, 0 plus a negative 7. 0 plus anything is the number I'm with. Later on, we'll define that as the identity function. Therefore, this is going to be a negative 7, actually the identity property, but we'll talk about that later. Number 5, they're the different signs. Therefore, what we're going to do is subtract. 75 minus 75 is 0, and 0 is neutral. It has no positive or negative value. Number 6, 45 plus a negative 15. Again, different signs. Therefore, I want to subtract. 45 minus 15 is going to give me 30. My solution is 30. But I want to take a look at 45 is bigger than just 15. Since 45 is positive, my solution is positive. I don't need to put a symbol in front of that. Continuing, now I have more than just two numbers, but I'm still going to work with two numbers. I can start at the end, start at the beginning, or work in the middle as long as I'm doing all addition. But we're going to work from left to right because that's actually our rules of order of operations, work left to right. So I'm going to copy the problem down, and I'm going to just bring down my plus 9 and bring down my plus 10. And now I'm going to work with these two numbers. Negative 4, negative 8, same sign combine, I get 12, and I use the sign. Now I'm going to work with the next two numbers, a negative 12 plus a positive 9. Different sign subtract, 12 minus 9 is 3. 12 is bigger than 9, it's negative, that's a negative 3 plus 10. Different sign subtract, 10 minus 3 is 7. 10 is bigger than 3, 10 is positive, my solution is positive 7. Again, order of operations working left to right. I do 2 at a time, bring down my plus -12 and plus 4. 15 plus a -8, different sign, subtract. 15 minus 8 is 7. 15 is bigger than 8, therefore it's positive. My solution is positive. 7 plus a -12, different sign, subtract. 12 minus 7 is 5. 12 is bigger than 7, so I'm going to use the sign of the 12, which is negative, plus 4. Bring down my plus 4, that is. Different sign, subtract. 5 minus 4 is 1. 5 is bigger than 4, and 5 is negative, therefore that's a -1. Without adding, can we tell whether each sum is positive, negative, or 0? Explain your answer. In this situation, I'm not going to add these together, but I can see that they are different signs, and what I want to do is subtract. And when I subtract, the 9 is bigger than the 7, so therefore this is going to be negative. Therefore, the integer that is negative is larger than my positive integer, and therefore it's going to be negative. Number 2, my positive integer is bigger than my negative integer. In this situation, I'm going to have a positive solution because I'm going to subtract. Here, they are opposites. 8 and -8 are opposites, and we know they're the same distance from 0, and when I combine them, I'm going to get a solution of 0. Now what I want to do is compare, and I want to use greater than, less than, or equal to complete each statement. Again, I want to copy the problem. And as before, I want to simplify both sides first and then make a determination. So I'm going to copy the left, copy the right, and I'm going to take the absolute value of a -18, which is 18, plus a -12. And that's different signs, so I subtract. 18 minus 12 is 6. And 18 is bigger than 12, and therefore it's positive. My solution is positive. On the right side, I bring down my -28, plus the absolute value of 35 is 35. There are different signs, so I want to subtract. 35 minus 28 is going to give me 7. 35 is bigger than 28, therefore it's a positive 7. And 6 is less than 7. Therefore, my expression on the left is less than my expression on the right. I'm going to follow the same process on the next example. I have the absolute value of 12, which is 12, plus the absolute value of a -15 is 15, plus a -22. I work on the first two numbers, my order of operations. They're both positive, so I'm going to same sign combine them, which is 27 plus a -22. Different sign subtract, that gives me 5. 27 is bigger than 22, it's positive, therefore my 5 is positive. Let's work on the right side, a -18 plus the absolute value of a -25 is 25 plus a -6. Order of operations, work left to right, a -18 plus 25, different sign subtract. 25 minus 18 is 7. 25 is bigger than 18, therefore my solution is positive. Bring down my plus -6. Different sign subtract. 7 minus 6 is 1. Positive 7 is bigger than 6, therefore this is positive. My solution is positive. Now I take a look. 5 is greater than 1. Therefore, my left expression is bigger than my right expression. Here on my last slide, I have my Harley motorcycle weighs 312 pounds more than 425-pound Honda Shadow. Find the weight of the Harley motorcycle. Well, in this situation, my Harley weighs 312 more pounds than my Honda Shadow. Therefore, I'm going to take 425 plus 312, and I want to find the weight of the Harley, and therefore it's going to be the sum of these two. And that's going to give me 737 pounds is the weight of the Harley Davidson.